Welcome to Mountain Bike Physics, Uniformly Accelerated Motion. Here's our problem. Chris from mountainbiketips.com approaches this downhill section of single track with a velocity of 29.9 kilometers per hour. He needs to bleed some speed or he might wipe out. He applies his brakes and slows down with a constant acceleration. After 1.23 seconds, he has traveled 6.00 meters. What is his acceleration and what is his final speed? All right, we're going to go ahead and start solving this problem. First thing we need to do is convert kilometers per hour to meters per second, so we get all our units in the right form. The answer there is going to be 8.31 meters per second is our initial velocity. Now that we know that, we can go ahead and list what we do know to solve this story problem. We know that the change in time is 1.23 seconds. We know that Chris travels 6.00 meters in this time. We know the initial velocity, we just found it by converting, is 8.31 meters per second. We do not know the final velocity or acceleration in this problem. We're going to solve for acceleration first since it happens first on the trail. We're going to use this equation. Delta x is equal to initial velocity times delta t plus 1/2 acceleration times delta t squared. We're going to go ahead and rearrange this equation to ultimately find acceleration. Could solve this problem many ways, but choose to do it this way. All right, so we are going to subtract initial velocity delta t from both sides to get this equation. And then we're going to divide through by 1/2 delta t squared to find acceleration. So acceleration set up to look like this. Delta x minus initial velocity delta t divided by 0.5 or 1/2 times delta t squared. Let's go ahead and plug in our values, solve for acceleration. 6 meters minus our initial velocity of 8.31 meters per second times 1.23 seconds divided by 0.5 times 1.23 seconds squared. Our acceleration, negative 5.58 meters per second. We'll now use the acceleration to solve for final velocity. I'm going to go ahead and use this equation. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times delta x. Take the square root of both sides to get Vf is equal to the square root of Vi squared plus 2 acceleration delta x. We'll plug in our values. Final velocity is going to be equal to the square root of 8.31 meters per second squared plus 2 times our acceleration, 5.58 negative meters per second squared, times our displacement of 6.00 meters. Our final velocity, 2.10 meters per second.